A team of NASA scientists has developed an interactive tool to reveal how the melting of Earth's ice sheets could affect cities around the world. The tool relies on sea level fingerprints, accounting for the non-uniform pattern of sea level change to reveal the potential impacts on 293 major cities. And the map reveals one ice sheet could have vastly different effects on certain areas of the world, depending on which part melts. Click and drag the map to see how different areas of the world are affected. The tool relies on sea level fingerprints, accounting for the non-uniform pattern of sea level change to reveal the potential impacts on 293 major cities. The phenomenon alters Earth's gravity field and the elastic deformation of the solid Earth, the researchers from NASA's Jet Propulsion Lab explain. If the western part of the Greenland ice sheet were to melt, for example, London would see significant effects. But if the northeastern side were instead to melt, New York would feel the impact. As ice sheets and glaciers melt, sea level rise around the world is not uniform.The phenomenon alters Earth's gravity field and the elastic deformation of the solid Earth, the researchers from NASA's Jet Propulsion Lab explain. This causes patterns that vary across the globe.The tool, called Gradient Fingerprint Mapping, GFM, shows how locations of the Antarctic and Greenland drainage systems affect local sea level rise predictions. We exploit an advanced mathematical property of adjoint systems and determine the exact gradient of sea level fingerprints with respect to local variations in the ice thickness of all of the world's ice drainage systems, the researchers explain in the study published to Science Advances. By exhaustively mapping these fingerprint gradients, we form a new diagnosis tool, henceforth referred to as Gradient Fingerprint Mapping, GFM, that readily allows for improved assessments of future coastal inundation or emergence. For the southern hemisphere, the researchers say parts of the Antarctic ice sheet could dramatically affect Sydney, Australia. As Earth's conditions continue to change, the experts say the tool can be modified for more accurate predictions. In a study published this past September, scientists revealed they directly observed sea level fingerprints for the first time. Scientists have a solid understanding of the physics of sea level fingerprints, but we've never had a direct detection of the phenomenon until now, said co-author of the study Dr Isabella Velicogna, UC Professor of Earth Systems Science and JPL research scientist, at the time. Sea level fingerprints are patterns of sea level variability around the world resulting from changes in water storage on Earth's continents and in the massive ice sheets. As ice sheets and glaciers undergo climate-related melting, they change the Earth's gravity field, leading to sea level changes that are not uniform around the planet. For example, when a glacier melts and loses ice mass, its gravitational attraction is reduced. Sea level rise fingerprints calculated from observations of mass changes in Greenland, Antarctica, continental glaciers and ice caps and land water storage made by the GRACE satellites between January 2003 to April 2014. As such, ocean waters nearby move away, causing sea level to rise faster far away from the glacier. This resulting pattern in sea level change is known as a sea level fingerprint. In certain areas, particularly in Earth's middle and low latitudes, are hit even harder, and Greenland and Antarctica contribute differently to the process. For example, sea level rise in California and Florida caused by the melting of the Antarctic ice sheet is up to 52% greater than its average effect on the rest of the world. To calculate sea level fingerprints associated with melting ice sheets, glaciers and changes in land water storage, the team used gravity data collected by the twin satellites of the US-German Gravity Recovery and Climate Experiment, GRACE, between April 2002 and October 2014. During that 12-year period, the loss of mass from land ice and from changes in land water storage increased global average sea level by approximately 0.07 inches, 1.8 millimeters, per year. About 43% of the increased water mass came from Greenland, 16% from Antarctica and 30% from mountain glaciers. The researchers verified their calculations using reading of ocean bottom pressure from stations in the tropics.